guys, welcome to our channel. This is Science Lectures. Thank you for being with us. Please subscribe, consider subscribing, comment in the comment section and hit the like button. Then hit the notification bell and we'll be informing if we put any new videos. So today we are going to look at vesicular transport, and vesicular transport is under active transport because for us to have vesicular transport we need energy in form of ATP. So we are going to look at vesicular transport, and vesicular transport is divided into two basically. That is excytosis and endocytosis. So when we talk of vesicular transport, we are transporting molecules with the aid of vesicles. We are transporting them using vesicles, and it is divided into an excytosis and endocytosis. So excytosis has two words. If it's broken down, it has exo which means out, then cyto, which comes from cell. So that means in excytosis we are transporting molecules outside the cell. So exo is outside the cell. Then endocytosis, we have the term endo, which means inside. Then cytosis, cyto, which brings in cell. So endocytosis will have molecules entering the cell. So that is a distinction between endocytosis and exocytosis. Then we are going to further look at, we are going to break further. Exocytosis is independent, but under endocytosis, we have other forms of endocytosis. We have pinocytosis under pinocytosis. We have phagocytosis, phago with a P, phagocytosis. And finally, we have receptor-mediated endocytosis. Receptor-mediated endocytosis is the final one. So we'll start off with exocytosis. In exocytosis is simply transportation of molecules. Exocytosis, transportation of molecules outside the cell. So we are transporting molecules outside the cell. Exocytosis can be very important in a cell, in that it can help in excretion of materials, waste products, excretion of wastes from the cell. So we can excrete waste from the cell by simply the aid of exocytosis. Then it can also aid in transmission of substances like neurotransmitter molecules. So we can have neurotransmitters moving outside a cell with the aid of exocytosis. Then another important thing we need to note about exocytosis, where it can be very important, in transportation of substances like mucin within, let's say, if we want mucus to go within the respiratory tract, it will be aided with exocytosis. So if this is our cell and exocytosis is to happen, let's say we are having our molecule A, and we want, let's say we are having molecule A, and we want molecule A to move out of the cell. Let's say it is in a vesicle. The vesicle will come and attach onto the cell membrane and will exit the molecule. So this molecule exited out of the cell can be an excretory waste, it can be a neurotransmitter, it can be a mucus in the respiratory tract. So that is simply exocytosis as a form of vesicular transport. So we'll have a vesicle transporting the molecule on outside of the cell. So that is it for exocytosis. Now let's have a look at endocytosis. Remember we said endo means inside, cyto is a cell. So we are transporting inside the cell. So we have three terms there. We have three divisions under endocytosis. That's pinocytosis, phagocytosis, receptor-mediated endocytosis. However, these processes require energy in form of ATP. So you should know that vesicular transport will have transport in vesicles, but in presence of energy in form of adenosine triphosphate. So that should be at the back of your mind. So we are going to look at breakdown endocytosis. Let's start with pinocytosis. Pinocytosis. Pino means drinking. Pino means drink. So means drink. So drink, pinocytosis in other words is cell drinking. We can call it cell drinking. Pinocytosis. So we'll have a cell taking in an aqueous solution or a fluid, or it will take in solutes. So we are having entry of solutes into the cell, solutes or any other fluids into the cell. So that is what we refer to as cell drinking or pinocytosis. So what happens, what basically happens in pinocytosis? If this is our cell, let's say this is a cell, and we have a solute. Let's say we have a solute around the cell. This solute will be taken up by the cell, by this cell. And when the solute is taken up by the cell, let's say the solute enters, we'll have an invagination. So the cell is taking up the solute and we form an invagination. Invagination forms. Then this invagination that forms then later develops into a pouch. The invagination forms a pouch, and that pouch is containing let's say this is a pouch. The pouch is containing the solute. The pouch later detaches. The pouch will later detaches off from the cell membrane, and it will form a vesicle. So this is what will happen now. Let's imagine that is our cell, then a pouch, then invagination of the membrane to form a pouch, which pouch later detaches off. And in detaching off, it will form a vesicle, which is referred to as a pinocytic vesicle. Pinocytic vesicle. So this pinocytic vesicle is the one that contains the solute inside there. So what happens is that the vesicle will now be broken down. The outer layer of the vesicle will be broken down, and the solute will be distributed into the cell. So that is how pinocytosis happens inside the cell. And this pinocytosis is common in places where, like in the intestines, where absorption of food substances takes place, like in the intestines, specifically small intestines where absorption takes place. This is how absorption of the solute materials will take place. So we are saying pinocytosis, or also known as cell drinking. Why? Because we have entry of solids, of fluids into the cell, and what happens is that the solute comes in, and there is invagination of the membrane to form a pouch, which pouch will be filled with the solids and later detaches off from the cell membrane, forming a pinocytic vesicle, which pinocytic vesicle will distribute the solute contents into the cell. So that is basically pinocytosis. So let's have a look at another form of endocytosis, and that is phagocytosis. Phagocytosis. So when you hear of the word phagocytosis, the term phagocyte can come into your mind, maybe phagocyte, and we know phagocytes in our body are cells. We can give examples of cells like white blood cells. The white blood cells can be a good example of the phagocytes. So in phagocytosis, we give another name for pinocytosis as cell drinking. We can say phagocytosis is the opposite of cell drinking, and that is cell eating. Cell eating. Why? Because in this case now we are having larger molecules that are larger than solids, larger molecules being taken up by a cell, so taken up into the cell, these larger molecules. So that is it with phagocytosis. Now, how is phagocytosis relevant in the body? Let's think of a white blood cell or a neutrophil. Let's say we are having a neutrophil or white blood cell. And in fact, let me sketch it this way. Let's say we are having our white blood cell with no specific shape. So if this is its nucleus, the white blood cell, and we have bacterial cells moving around in our blood, rotating in the blood, a bacterial cell. So this bacterial cell can be engulfed by the white blood cell through the process known as phagocytosis. And for phagocytosis to happen, we very well know that we need pseudopods. Development of pseudopods. If this is a cell, it should have those foot-like structures, the false feet or pseudopods. Their formation is aided by actin filaments, like we saw in our video for cytoskeleton. If you didn't see the video, you can please check it on our channel. The video is there about the cytoskeleton, where we gave a brief about the actin filaments. So phagocytosis, you think of the white blood cell or other cells that can engulf other cells like bacterial cells. So I want us to look at this process in detail, how it happens, how phagocytosis happens within the cell. So let's imagine we are having the white blood cell, and we have some foreigners, bacterial cell. So we have bacteria as foreign cells. What happens when they come into contact? This is the white blood cell, comes into contact with the bacterial cell. Let's say this is the bacterial cell. Then the white blood cell will form, it has the pseudopods formed by the presence of the actin filaments, action of the actin filaments, so it engulfs the bacterial cell. So let's say this is the bacterial cell. When it is engulfed, there is invagination of the cell membrane. Then after invagination of the cell membrane, to form a pouch. A pouch which later detaches off from the cell membrane. So that pouch detaches off from the cell membrane. And the pouch, in other words, this is what happens diagrammatically. Let's say we are having the bacterial cell inside there, then the pouch later detaches off from the cell membrane. Then when it detaches off, it will form a vesicle inside the cell. So it will be enclosed in a vesicle with the aid of the cell membrane inside the cell. And this vesicle, where it is enclosed, when it is enclosed in a vesicle, it forms a structure known as a phagosome. So we shall have formation of a phagosome, structure known as a phagosome. The moment we form, so we have our phagosome inside our cell, our white blood cell. So the moment we form a phagosome, there will be pumping. In fact, inside the cell, you just imagine inside the cell, we also have, let's say this is now my phagosome. This is the phagosome. Inside the same cell, we have lysosomes. This is the lysosome. It contains, and we know lysosomes contain hydrolytic enzymes. Let's imagine inside there are many hydrolytic enzymes. They can be nucleases, proteases, acid phosphatases inside the lysosomes. And we said in our video of the cell organelles that lysosomes contain hydrolytic enzymes which work best at a pH, at an acidic pH of around 5, pH of 5. So this implies that for our lysosomes to work effectively, they require pH of 5, pH of around 5. So the phagosome formed, there will be pumping in of hydrogen ions into the phagosome. So let's imagine hydrogen ions are being pumped into the phagosome. Hydrogen ions into the phagosome. Hydrogen ions into the phagosome. Why do we need hydrogen ions pumped into the phagosome? To create an acidic pH that is favorable for work for the activity of the hydrolytic enzymes found in the lysosome. So there is pumping in of hydrogen ions. And when you hear pumping in of hydrogen ions, this process requires ATP, energy in form of ATP. That is why we say phagocytosis under vesicular transport is a form of active transport, because we are incurring in energy in form of ATP to provide the proton for an acidic pH. So after pumping in hydrogen ions, this phagosome is can now interact with the lysosome. So the lysosome will come and interact with the phagosome. The moment the two are together, the lysosome and the phagosome, they form a structure known as combination of both lysosome plus the phagosome. Lysosome and phagosome will form a phagolysosome. So we'll form a phagolysosome. And this phagolysosome formed is a combination of the phagosome and the lysosome. So the hydrolytic enzymes in the lysosome will break down the phagosome, and when they break down the phagosome, will form a secondary lysosome. Secondary lysosome. Now this secondary lysosome contains the particles, the materials of the bacteria that were broken down. So these components inside the secondary lysosome, let's imagine this is my secondary lysosome. So after having the secondary lysosome, the particles can either be released into or released outside the cell. And you might find that particles that are released out of the cell can stimulate other immune responses within this cell. So a summary of phagocytosis, a brief of phagocytosis, we said it's cell eating. So a cell is taking in a larger molecule as compared to solids. A larger molecule like a white blood cell taking in a bacterial cell. And this happens when we have pseudopods forming due to the aid of actin. The pseudopods will aid in engulfing of the bacteria. When the bacteria is engulfed, it will form a pouch or an invagination that forms a pouch that is later detached off from the cell membrane. And when it detaches off from the cell membrane, it forms a phagosome. So when we have our phagosome formed inside there, protons will be pumped into the phagosome in presence of energy in form of ATP. So the protons provide an acidic pH for effective working of the lysosomes, hydrolytic enzymes in the lysosomes. Now we'll have combination of the phagosome and the lysosome to form the phagolysosome, which phagolysosome will aid in the breakdown. That combination will aid in the breakdown of the bacteria with the aid of the hydrolytic enzymes in the lysosome, and later we'll have a secondary lysosome. Then waste products will be released either inside or outside of the cell. So that is it for phagocytosis.